Hello and welcome to Fun Maths, where we make maths easy and fun. Today, we're learning how to add and subtract fractions like a pro. Whether you're a student, a teacher, or just brushing up on your skills, this lesson is for you. So, grab a pen and let's dive in. To add and subtract fractions, we are going to start with fractions with similar denominators. To add or subtract fractions with the same denominators, add or subtract the numerator and keep the denominator the same. Let's take some examples. First, 5 over 9 plus 7 over 9. Now, you notice that the both of them have the same denominators. So what you just simply need to do is to take one of the denominator, then add up your numerator, 5 plus 7. And that will just simply be 12 over 9. 12 over 9 is an improper fraction, so we can change that improper fraction into a mixed number. If you don't know how to change improper fraction to a mixed number, check out my video on that. Now, to do this, I will just say 12 divided by 9, that's 1. That is how many 9 will I see inside of 12? That's 1, with a remainder of 3. The 3 becomes, my remainder becomes my new numerator, and my denominator remains the same. So that's one whole number, 3 over 9. I can even take 3 over 9 to the lowest term. That is, I can look for a common factor that can divide both 3 and 9. In this case, 3 can divide 3 and 3 can divide 9. So 3 divided by 3 is 1. 9 divided by 3 is 3. So my final answer becomes one whole number, 1 over 3. Let's take the second example. 3 over 5 minus 1 over 5. They both have the same denominator. So I will just take one of the denominator and I will subtract the numerator. 3 minus 1 is 2. So that gives us 2 over 5. 2 over 5 is already in the lowest term, and that's my answer to that question. So that's how to add or subtract fractions with the same denominator. Let's now go to fractions with different denominators. To add or subtract fractions with different denominators, find the LCM of the denominator. Then add or subtract the numerator and keep the denominator the same. Let's take some examples. We want to add 3 over 4 plus 1 over 8. Now, I taught you how to find the LCM of numbers. So to add up this fraction, because the denominators are different, we need to find the LCM of the denominators. So I'll quickly do that for you. So we have 4 and we have 8. What can divide 4 or 8 or both? 2. 4 divided by 2 is 2. 8 divided by 2 is 4. 2 can divide again. 2 divided by 2 is 1. 4 divided by 2 is 2. 2 can divide again. 1 comes down and 2 divided by 2 is 1. So my LCM becomes 2 multiplied by 2 multiplied by 2. So 2 times 2 times 2 simply gives us 8. So the LCM of 4 and 8 is 8. Now I'll come down to my fractions and I'll write my denominator of 8 on both sides. Don't forget that we are adding up these fractions. Now, what will I multiply by 4 to give me 8? That's 2. 4 times 2 is 8. So I will do the same thing for the numerator. 3 times 2 will become 6. That simply means that 3 over 4 is an equivalent fraction, is equivalent to 6 over 8. 1 over 8, what would I multiply by 8 to get 8? Is obviously 1. So it means that 1 over 8 still becomes 1 over 8. Now, I can now add up my fraction using the same idea I used in the previous example. Because the denominators are now the same, I will simply take one of the denominator, then I will add up my numerator, 6 plus 1. My final answer simply becomes 7 over 8. And that's the answer to the question. Let's take another example. 1 over 6 minus 1 over 9. We have different denominators, so I need to find the LCM of the denominators before I can add. Now, what is the LCM of 6 and 9? What can divide 6 and 9? 2. Or 9. 2 can divide 6. So 6 divided by 2 is 3. 9 divided by 2. Because there will be a remainder, I'll bring down the 9. Now, what can divide both or any of them? 3 can divide. 3 divided by 3 is 1. 9 divided by 3 is 3. 3 can divide 3, so I'll bring down my 1. 3 divided by 3 gives me 1. So when I have 1 on both sides, I can now multiply my prime numbers. 2 times 3 is 6, and 6 times 3 is 18. So therefore, my LCM is 18. So I'll write out my LCM underneath the two fractions. Now, what will I multiply by 6 to get 18? Obviously 3. So I'll multiply the numerator by 3. 1 times 3 is also 3. Then, what would I multiply by 9 to get 18? That's 2. 9 times 2 is 18. So 1 times 2 will simply be 2. Because I now have similar denominators, I will pick up one of the denominator, then I will subtract the numerator. 3 minus 2. So my final answer simply becomes 1 over 18. And that's the answer to the question. So that's how to add or subtract fractions with different denominators. Let's go into adding mixed numbers. When you want to add mixed numbers, there's a very simple way of doing this. Firstly, write out your mixed number in vertical form, as in this form: 3 over 20 plus one whole number 1 over 5. Now, after writing out your fraction in vertical form, ensure that the denominators of the fractions are similar. In this case, we have 20 and we have 5, so I need to find the LCM of the denominators. 20 and 5. What can divide 20 or 5? 2. 2 in 20 is 10. 2 in 5, because there will be a remainder, I'll bring down 5. 2 can divide again. 10 divided by 2 is 5. I'll bring down 5 again. And 5 divided by 5 is 1, 1. So my LCM is simply 2 times 2 times 5, which is 20. So the LCM of 20 and 5 is 20. Now, I will simply rewrite my fractions such that they both have the same denominator. In this case, 3. So over 20. Then I have 1 over 20. Now, what would I multiply by 20 to get 20? Obviously 1. So 7 times 1 is 7. I will do the same thing for the denominator, for the second fraction. What would I multiply by 5 to get 20? That's 4. 1 times 4 is 4. So I have arranged my fractions such that they both have the same denominator. So what do I do next? First, add up your fractions. In this case, 7 plus 4 is 11. So I have 11 over 20. Then 3 plus 1 is 4. So the answer to my question is 4 whole number 11 over 20. Let's go to the second fraction. 3 whole number 5 over 8 plus 2 whole number 2 over 7. So 3 whole number 5 over 8 plus 2 whole number 2 over 7. Firstly, ensure that they both have the same denominator. So I'll find the LCM of 8 and 7. What can divide 8 or 7? 2. 8 divided by 2 is 4. 7 divided by 2, we have a remainder, so I'll bring down my 7. 2 can divide again. 4 divided by 2 is 2. 7 divided by 2, we have a remainder, so I'll bring my 7 down again. 2 can divide again. 2 divided by 2 is 1. I'll bring down my 7. Then 7 can divide 7. Here is 1 and here is 1. So my LCM becomes 2 times 2 times 2 times 7, which gives us 2 times 2 is 4. 4 times 2 is 8. 8 times 7 is 56. So I will rewrite my fractions such that they both have the same denominator, 56, then 2 whole number over 56. Now, what would I multiply by 8 to get 56? That's 7. 8 times 7 is 56. So 5 times 7 will simply be 35. I will do the same thing for the other one. 7 times 8 is 56. 2 times 8 will be 16. Now, all I have to do is to add up my whole numbers. 2 plus 3 is 5. Then I can now add up my numerator, then have a similar denominator. So in this case, we have 5 whole number. Now, 35 plus 16, that's just simply 51 over 56. So we have simply added up those fractions. Next, we are going to subtract mixed numbers. To subtract mixed numbers, we use the same method as we did for addition. First, I'll write it out in vertical form, then ensure that the fractions have similar denominators. In this case, the denominators are 8 and 4, so I have to find the LCM of the denominators. So what can divide 8 and 4? That's 2. This is 4 and this is 2. 2 can divide again. 4 divided by 2 is 2. 2 divided by 2 is 1. 2 can divide again. 2 divided by 2 is 1. Then I'll bring down 1. So my LCM is simply 2 times 2 times 2. And that's 8. So I'll rewrite my fraction such that they both have similar denominators. Now, what would I multiply by 8 to get 8? Obviously 1. So 1 times 8 is 8. 5 times 1 will be 5. So I'll write down 5. What would I multiply by 4 to get 8? That's 2. 4 times 2 is 8. 3 times 2 will give us 6. Okay, now notice that if I decide to subtract my numerators, 5 minus 6, it's not possible. I can't take away 6 from 5. So what do I do? Please listen attentively. Our whole number for the first fraction is 3. If I borrow 1 from 3, it becomes 2. So I'll borrow 1 from this 3, it becomes 2. Now, whatever you have borrowed becomes the same thing as the numerator. Why is this possible? If I have 3 and I borrow 1 from 3, and notice that 2 plus 1 gives us 3. This one whole number can also be written as 8 over 8. So in that case, I have written 3 as 2, then 8 over 8. Now, if I add that 8 to 5, that simply gives us 13 over 8. So we now have two whole number, 13 over 8, because 8 over 8 plus 5 over 8 is 13 over 8. Then the other fraction remains the same. What did I do? 3 was broken down into 2 plus 1. 1 is the same thing as 8 over 8. So if I add 8 over 8 to 5 over 8, it simply gives us 13 over 8. So I now have 13 over 8 minus one whole number, 6 over 8. If I subtract my numerator, I'll simply have 13 minus 6, that's 7 over 8. Then 2 minus 1 is 1. So I have successfully subtracted the fraction. Let's take the second example. 7 minus one whole number, 1 over 3. If I write this in vertical form, I'll have 7 minus one whole number, 1 over 3. You notice that for the fraction at the top, it doesn't have a fractional part. It only has a whole number part. It means that to create a fractional part, I'll borrow 1 from the whole number part. Please note this. I'll borrow 1 from the whole number part, meaning if I borrow 1 from 7, I'll have 6 left. So if I rewrite this, it will be 6 whole number. Now, that one that I've borrowed, I can rewrite it as 3 over 3. So what did I do? I ensured that that one had the same denominator as the fraction in the at the bottom. So that one becomes 3 over 3. So I simply rewrote 7 as 6 whole number, 3 over 3, because 3 over 3 is the same thing as 1. Then the one on the bottom remains the same, one whole number, 1 over 3. Now, I now have whole numbers on both sides and fractions on both sides, and both fractions have the same denominators already. So to subtract, I'll subtract the whole number, 6 minus 1, and that's 5. Then 3 minus 1, that's the numerator. 3 minus 1 simply gives us 2 over 3. So that's how to subtract fractions whereby one of the fraction is just a whole number. You convert that whole number into a fraction by ensuring that it has the same denominator as the other fraction. Note that 3 over 3 is same as 1. So 6 whole number 3 over 3 is the same thing as 7. Great job, everyone. Today, we'll learn how to add and subtract fractions with the same and different denominators. Remember, keep the denominators the same when possible. Find the LCM when denominators are different, and always simplify your answers when needed. Practice time. Kindly pause the video and try out this practice question. I would really love to see your answer in the comments. If you found this lesson helpful, give the video a thumbs up, subscribe to my channel, and hit the bell icon for more maths lessons. See you in the next video. Happy learning!